Okay, good morning. Make sure that if you have a question, you'll type it in, and I talk about this chapter, I can address your questions. But like I mentioned it many times before, if you have a real question about a chapter, it's better to post it on discussion board and let let's say, it seems like my okay, let's see if that works better. Anyway, so make sure that you type in your questions if you have any. Okay, so let's start on chapter 5, which is talking about repetition. So as you're reading through this chapter, okay, make sure that you keep your pseudocode knowledge and flowchart knowledge in mind as you are designing your code with repetition. It's still going to be important, but the most important aspect is going to be that somehow we need to make sure that we can enter a loop and also we can exit a loop. So if you look at the basic flowchart shape, right? This is our basic flowchart shape, but in looping we have to have the primer. Just going to call that P. Then we have to have a logic. The logic is pretty much the same thing like in a previous chapter in the selection statements. Okay, but before we get into the loop, we need to have a priming value, and then we have the logic that uses the priming value, and then in the body of the loop we need to update. Our main concern is going to be how do we exit? How do we exit out of the loop when we are in the loop? So in this case, you guys are going to have a lot of problem, or sometime you're going to have some problems in infinite loops because you cannot exit out of them. Now, as far as the looping is concerned, okay, what we need to look at is when do we use what type of syntax for loops, and that's when you're going to see the different kind of controls. Okay, if you look at the different kind of controls. Now, if you know how many times the loop needs to iterate, or how many times the loop has to execute, if you know the exact number, let's say you're writing a game and you have 3 lives, then you know that you can only execute the loop 3 times. So in that case, you're using the counter control because you are counting the number of loops and you know exactly how many loops they're supposed to be. Now, if you have a sentinel control, a sentinel is when you're asking somebody yes, no, let's say yes, no type of questions. And you're going to have something, like you want to play another game. And the user can say yes. And in that case, it's not about how many times you lost the game, but how many times you want to play the game. And I'm not limiting how many times you want to play the game. But if you're done playing the game, then at the question, you can answer no. So in that case, the no becomes the sentinel, what you're looking for. Or sometimes you might see Q for quit. So you might say, do you want to play another game? Y for yes and Q for quit. Those would be sentinels. Now if we have flat controls, we're taking advantage of a structure. So if you look at, or if you remember how we process files, right? So we have the IF stream data type, and when we create a pointer to the IF stream data type, that is a structure, that's an object. So inside the object, you can have different flags. So as we are reading information and we've reached the end of the file, there is a marker at the end of the file that you don't control. The object controls it. And those are going to be called flags. And one of those flags is the end of the file. So the pointer to the input file stream can check if it reached the end of the file. So in that case, it's not the user decides when the user feel like you need to stop reading the data, but the file, the object itself actually controls it. So let's see if you have a file. So here's the file, and you have entries in the file that you're going to be reading, okay? And one of the entry is, let's say, -1, okay? And the file itself has a marker end of the file, okay? Now, if you only want to read the first 3 lines of the file, then it is a counter. Okay. A counter control, because you know that you only want to read 3 lines of the file. Now, within the file, you can have a special value. So let's say this file contains ages of people. Now you know that the age is going to be only positive value. So if we put in a negative value, that can be the sentinel, even though we have more lines after that. But maybe I need to only read people in dollars. And in dollars we have a lot of people, and I'm reading the ages. Now the number of people in dollars changes. So I don't know how many lines of code to read. But as soon as I read -1, I can see that that's the end of the dollars group. And then you want to read ages for Los Angeles, it might be a different group. But in this case, I'm using the -1 as a sentinel. A sentinel to show that is the end of my read. Now the file itself is an object, and that object has a flag. So in that case, you can control the read by flag. So there's not one way or one structure that you would need to consider even for file operation. It depends what is it that you want to accomplish. And that's how you decide how you're going to control your loop. Okay, so if we have a break or continue statement, in that case, what we have is let's say a loop. Okay, and the loop normally continues on to the next value. Right? But within that loop, you can have a logical statement that will decide if you have other statements after that. Okay? If you want to continue on, this is to continue on. So continue will redraw this. Okay, so we have a loop that has some statements, and finally we have the update. Okay, and we might have a logical statement that says do the update but continue on to the next value. Okay, so this is the update. You still have to do the update, otherwise you're going to be in an infinite loop. But skip the statements. So keep the statements and continue on to the next value. Or this logical statement can tell you to done processing the loop and exit out of the loop. So in that case, that's going to be break. Okay. So think about it just like with the switch statement in the previous section, previous chapter, the selection statements. If you reached a statement, let's say a case statement, you wanted to exit out of that. The rest of the switch statement, you use the keyword break. So that works pretty much the same way in a loop. If you're done processing the loop and you checked some value and you don't want to finish the iteration, you don't want to go and loop around 100,000 more times, then you can just break. The continue will just ignore the rest of the statements. So that's going to be an important concept in this chapter. So why do we need repetition? We need to use efficiently variables. If you have 100 values, you don't want to create 100 variables. You can just reuse those memory addresses. You can input and add on average multiple numbers using a limited number of variables. In that case, we use like a total counter, a running total, or sometimes we call it an accumulator. With the accumulator, what you can do is count values. So how do we add 5 numbers, declare a variable, and we can put in values, and as we create the new values or enter the new values, we add the values together. So in that case, we're using accumulator. So the while loop structure, that's what we use in pseudocode, just the while keyword and end while. As you can see in pseudocode, we use end while, but in the actual C++ language, we just use while, and then in parentheses we put the expression, the Boolean expression, and then we have the statement. Now look at it. That just says statements, not statements. If we have multiple statements, then we need to put in the brackets, the curly brackets around the statements. The statement's going to be executed when the expression becomes true, and when the expression is false, then we break out of this statement block, and that is the body of the loop. Okay, so expression, when it's true, then we have a statement. If the expression is false, then we continue on in the code. Okay, so in this example, this would be an example of a accumulator. So in this case, you can see that I equals 0 is the priming value. Now, if that is the priming value, we're using the same variable name I in order to check if we are allowed to get into the loop. And that's why the priming value is part of the Boolean expression that will control the loop. So it's also called the loop control variable. So you need to initialize the loop control variable, which is priming it. Then we're using the loop control variable to check if we exhausted the loop count. And if not, then we execute the loop body. And in this case, we add 5 to the loop control variable, and that is our update. In this case, we are going back into the loop to check if I is less than or equal to 20. And here you can see the sample run. Okay. Let's see. So the variable I is called the loop control variable, and the definition of the infinite loop that it continues to execute endlessly. And the way that you avoid it is by including a statement in the loop body that assures the exit condition is eventually met. Okay. Here we're looking at I equal 20. So that's the initial value. Now, if I is equal to 20, then the loop control variable is compared to 20. Well, 20 is equal to 20. So at the very first loop, the expression will be false. So in this case, the body of the loop will never execute. So the main ID is that you need to think about the initialization, the initial value. Then you need to look at the expression, and then you need to look at the update. Okay. So here the counter equals to 0, and then counter less than n is the expression, and counter plus plus, we're updating the counter, and the counter is the loop control variable, and we usually do that at the end. So when we have a sentinel value, then usually you would have an input from the user. So input from the user or input from the file would be okay. 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 So with the sentinel value, you have a user, some kind of an interaction. So with a counter control, you know exactly how many times the loop should execute. With a sentinel, you probably have some kind of a user interaction, and with the flag control, you automatically control by object properties. So that's how you're going to decide which type of a structure to use. So if you look at the example 5-5, which code comes with your book, okay, it's important to run all the examples in this chapter. Like I said, it's really important for all chapters. But here you need to look at the examples and make sure that you understand how the code is running, how the code is executing. Okay. So let's see, if you look at your project, and we're going to add an existing item. Let's say add the telephone number digits. Okay. Now you can see here that what is it that we're comparing with the while loop? Well, we're comparing the letter. Okay, so you've declared the letter, and now you are reading in a letter from a user. So you don't know what kind of letter the user is going to type in. But if it's anything else but a hash mark, then the loop will execute, and based on that loop, you need to validate if the user actually typed in something between an A and a Z. Remember, we can do this Boolean comparison because a character, which is our letter. Okay. A character is an integral data type, which is comparing the ASCII values. So we're really comparing ASCII values. And because ASCII values are an ordered list of characters, now you know that every letter that somebody types in is between A and Z. Now at that point, you look at the letter, and if somebody typed in A, B, C, A, B, or C, then you're going to display 2, and then you break. Okay, so at that point, you break out of the switch statement. Okay. Now, if somebody is not typing something in between A and B, and A and Z, then you want to display a message to them. Okay? And then enter another uppercase letter. Now you can see that that is the initial question. Right? So in this case, when we look at that, you have the logical statement. Before the logical statement, you read in a value, and you also had a message to type in a letter. Then you initialize the letter in the next input. So this is an output statement, this is an input statement. Then you have the logic. Within the logic, you make a decision what letter to display, and what number to display. Okay. And at that point, you look back around. But before you look back around, you have the same type of messages displayed. Where first of all, you display a message to enter a value, and then you do the update. So when you have the update was the priming value. Okay, so that was the priming value before we got into the loop, and after we are in the loop, we keep updating the values until we exit, because somebody did type in the hash mark. Okay. And then you can display the message to say goodbye. Okay. But the main thing is you can see this code, how the code operates, if you understand flowcharting and pseudocode, either or. Okay. But here's a sentinel, and in this case you're looking for the hash mark in order to have the sentinel that you're looking for. That will eventually take you out of the while loop. Okay. And when you're at the end of the while loop, so this is your update right here. And because we have an update, now we have a chance to compare a brand new letter in the next iteration of the loop. Okay, so that's going to be very important. So how do you design that kind of a code? And that's why you need to design your code, and you need to look at the code and decide how to write a program. So you can see that if somebody types in A, B, or C, then you need to display 2. Somebody types in D, E, or F, then you display 3. Somebody types in G, H, or I, then you display 4. So you have 3 possible letters to 1 number. So 3 to 1 mapping. So because it's 3 to 1, it's a really good choice to pick the switch statement, because that will give you the easiest to read 3 to 1 ratio, I guess. Okay. I mean, you can do the if statement as well, right? If, let's just call it L for letter. Letter is equals to A, or letter equals B, and so forth, right? Then C out 2. Okay, and then you can do an else if. So else if letter equals D, or letter equals, okay, so then letter equals E, letter equals F, then display C out, right? Okay, so you can do if, else if, else if, else if with the or Boolean operator, or you can just say case A, B, C, then display 2. Case D, C, D, E, F, display 3. It's up to you how you design it, but it's important to really look at the physical layout, in this case the phone buttons, in order to understand how to design your code. Okay, so now we have a flag control. Now the flag control is usually going to be a Boolean value. The Boolean value will control the actual loop. The expression is working the Boolean value, as you all know by now. So what you can do is have a Boolean value, and if the some kind of a condition met in the loop, then flip that Boolean value. So in this case, the loop control variable is found. How do we know that that is the loop control variable? Because that loop control variable's value controls if we are allowed or not allowed to get into the loop. So in this case, found is equal false. Now we have the exclamation point in front of it, so that means not false. Not false is true. So we are in the loop body. If the expression is true, then we're going to flip that found to true. So when we evaluate the expression and we negate the true, it becomes false. So why would you use something like this? This is a really common way of controlling the game. So in this case, the loop, let's say if this is a game, then I would say is 1. So instead of found, I would say is 1. Okay. And I would say, no, you didn't win the game yet. Okay. So when you negate it, it becomes true, and the loop is executing. Now, if you go to, let's say, your goal in the game is to get to a particular value. Now, that is an if statement inside the while loop. Okay. So if you don't get that particular value, then is 1, or in this case found, is still false. So that means you have not located that particular value yet. So you are keep continuing with the loop until you find that actual value. Now if you found that value, then you turn it to true, to show that you did win, you did locate that particular value. And at that point, when you go back into the loop, into the while loop to evaluate, now true going to be negated to false, and at that point the game ends, because you won the game. Okay, so it's kind of strange to look at it that why would I negate false just to get true? Because it's easier to read it. So if I have this variable is1, and I say is1 equals false, then as you're reading that statement, it's kind of like the English sentence that you would say, no, I did not win yet. So when you flip it to true, then it's going to be, oh yes, you did meet that criteria, and now you did win the game. Now when you did win the game, then there is no point iterating again. So at that point, the game ends, and then you display a message, congratulations, you won the game. So look at the syntax of different loops and try to find a way to really apply that kind of knowledge to a kind of a particular application. Where would you use that? Okay, so with the number guessing game, you can use the random number generator. The random number generator will generate a value, and in this case, I think the most important part of understanding random number generation. Let me just talk a little bit about that. Okay. So let's see. Okay. So let's see if we have a random number. 0, 1, 2, 3, 4. Okay. And let's see if I can get this to the proper place. Let's look at this mod operator. Okay, so let's see what happens if we are modding something by, let's say, 2. Okay. So if I call this x, okay, so let's say these are the x values. If I mod that x value by 2, okay, then we look at 0 mod 2 is 0 divided by 2 is 0, and the remainder is 0. 1 divided by 2 is 0, remainder is 1. 2 divided by 2, the answer is 1, the remainder is 0. 3 divided by 2 is 1, remainder is 1. 4 divided by 2 is 2, remainder is 0. 5 divided by 2 is 2, remainder is 1. 6 divided by 2 is 3, remainder is 0. 7 divided by 2 is 3, remainder 1. 8 divided by 2 is 4, remainder is 0. 9 divided by 2 is 4, but remainder is 1. Now let me change this to 3. 0 divided by 3 is 0, remainder is 0. 1 divided by 3 is 0, remainder is 1. 2 divided by 3 is 0, remainder is 2. 3 divided by 3 is 1, remainder is 0. Now you can go through this, and what you're going to see, or you should see, is a pattern emerges. So let's see what happens if it's 4. If we mod the number by 4, then we have 0, 1, 2, 3, 0, 1, 2, 3, 0, 1. What if we mod the value by 5? 0, 1, 2, 3, 4. 0, 2, 3, 4. Okay, so let's see what happens if you want to simulate tossing a die. Now how many values we have in a die? Well, it's going to be, let's say, in a die, we have 1 through 6. Now, what can we read out of this example I just showed you? Well, what I wanted you guys to look at is anytime a number, okay, this can be a random number. When the random number is modded by a particular value, then what you're going to have is a range that starts at 0 and ends at the mod value -1. Okay, see here the ranges. So how can we create a die that's going to have values from 1 through 6? Now the problem here is that what we're going to be able to generate, as far as we are concerned here, so what we're going to be able to generate is going to be 0 through 5, what we should be generating. Because you can see that with the random number generator, we're always going to be generating a random value, and if we mod that value with any other integer, we're always going to start at 0. So what our goal can be is creating a random value 0 through 5, and when we have those values, just add on to that, and that's going to ensure that we're going to have a range of 1 through 6. So that would be the basic idea of random number generation when it comes to games where humans are playing against computers. The computer just randomly generates something. So in our games, what you're going to have is srand, and you're going to send time null to that function. Now, what is that? In our case, what that's going to be is the seeding the random number generator. At that point, you're going to be able to call rand. Now, what is rand going to give us? Rand going to give us an integer value, a random integer value. And at that point, we're going to be modding that. Now, if there's going to be a die simulator, what would you mod it with? Remember what we need? We need 0 through 5. Okay? So what we're going to mod it with is 6. Okay? Why 6? Because modding random number with 6 will give us a range from 0 through 5. And at that point, what we can do is take that value that's going to be randomly generated 0 through 5 and then add 1 to it. Okay, so this would be a generic, or not really generic, it's a very specific example of random number generated in C++. But make sure that you understand that. Why is that +1 and why would you mod it with 6? Okay, so what if you are playing the card game, and in the card game you have 52 cards, right? So you want to generate a random distribution of those 52 cards as you're playing the card game. Then you can assign a suit and the value to every single card and the placement for those cards. So that's going to be 0 through 51, right? That's going to give us 52 cards. So how can you pull a random card out of a deck? Well, in that case, what we need to do is to generate a random value, and with the random value, right? So in that case, seeding the Actually, seeding the random number generator would be the same thing, but in that case you would say rand mod 52. What is that going to create? 0 through 51. Okay. And if you want to really look at it as 1 through 52 card numbers, then you can add 1 to that. And now you're simulating the deck of 52 cards. Okay, so I just wanted to make sure that you guys understand that concept when you are talking about the number guessing game. Okay, and that's where this range comes from. So why is that random number modded by 100? Because that's going to give us 0 through 99 random values, evenly distributed net random values from 0 through 99. And now you can, based on that, you can develop the logic of the game. Okay. So the end of the file controlled while loops are used in file operations. Or what you can use, you can also do it with the input stream. So either input stream or input file stream, it doesn't really matter, right? So so you could have that CIN also being a IF stream, and in that case CIN becomes the loop control variable, because the state of CIN controls how many times the loop will iterate. And then you having an update, and you can see that this and this line of code right here are exactly the same. And that's why when we learned about flowcharting, we just call that A, and then we are in the loop, and the loop iterates around, loops around, and this is also called A, right? So that's why you guys had those kind of exercises. So we have the expression right here. That's why you guys have the exercises that we never go up above in the flow chart. We don't go above A, right? But what we needed to do is we needed to make a copy of A, and that's what we're using right here, right now. In the CIN, this was a priming value, and this is the update. But you can see that CIN has a state, so that's why we are able to use CIN as a controller for the loop, and we don't have to say equal true, because the return value of CIN is going to be a Boolean value, so it can be used directly in the expression. Okay. So we can also specifically call a function. Okay, now this whole concept of function is kind of new to us, because we haven't really looked at the next chapter going to be controlling or considering functions. But right now, just think about iStream as a box. Okay? And that box we just mainly call the CIN. Right? So CIN is a box. Now within CIN we have a function that is EOF, and we're not sending anything to the function. So EOF. Now how do we get to that particular function within CIN? And that's when we're using the member access operator, which is called it. Okay, so CIN, and then we have the dot EOF, and then function call. Now the dot is the member access operator. So right now, just think about it. So as you see a dot, you are going inside the big box, and within that big box, you are pulling off some member functions. So the expressions can also be combined expressions, and we really can look at it as a Boolean expression. Okay? So in this case, what is it that you're trying to do? So you're allowing somebody, now it depends on what is the initial value of number of guesses. Let's say they start with 0. It starts with 0, you allow somebody to guess 5 times a number. Now within 5 times of guessing the number, you can also determine that somebody guessed the number correctly after the second trial. There is no point forcing the loop to execute 5 times when you already got the answer. You just have 5 trials. And that's why you have this combined expression, when you're combining the number of guesses allowed with the success, with the potential success of the guess. And here, again, is guessed initialized to false, false negated is true. So now you have, let's say, the first guess. First guess is, this is 0, 0, and 0 is less than 5? Yes, it is. So that's true. And did you guess it yet? No. So no negated is true. So true and true is true. So we can guess again. So as we're guessing again, the only update is guessed if you got the correct answer. If not, you only update the number of guesses. So second time around, 2 is less than 5, so that's true, and guess is still true because you're negating false. So let's say at the third trial, you're going to guess it correctly. So number of guesses is 2, 0, 1, 2, which is the third trial. So number of guesses is 2. 2 is less than 5. Yes, so it is true. And at that point, you guessed it correctly. So because you guessed it correctly, then you change the is guessed to true because you got the right number. Now what happens then? We're going to update the number of guesses. It's going to be 3. And we're going to see if we can guess again. Well, 3 is less than 5, so that's true. But now, is guessed is true, negated is going to be false. So now you are comparing true and false, and that's going to be false. That's going to be end of the game. So you can now display it to somebody. Congratulations, you have guessed the number on your third try. So that's how you would control that loop. So again, with the Fibonacci numbers, you might know a formula, and with this formula you have to take that literal formula or equation and make a loop out of it. And one of those examples is the Fibonacci number. So the initial numbers are going to be 1. So we know the initial numbers. But then we have a sequence of the same operation. The same operation is basically you have the previous and the prior to the previous numbers that you have to add. How many times? Well, n times. So that's going to be the n, going to be the control to the loop. And that's going to require an accumulator. So you have the initial values, right? So if we look at the nth Fibonacci number, So the end Fibonacci number, the values going to really start, or the loop going to start if somebody is asking for the third Fibonacci number, because the first Fibonacci number is just going to be 1. The second Fibonacci number is going to be 1. But the third Fibonacci number is going to be the sum of the prior two values. Okay? So in that case, you're going to have a if statement, right? And then else if it's the first one, if it's the second one, you're just returning a particular value. Else, right, we have to iterate around until we get the nth value. So this would be a really simplified flowchart for this program. So we have if, and then while. And that's going to be the basic concept for this particular program. Okay. So many times when you're designing the code, you don't understand how to start the code, because you might not be able to do it on a piece of paper. So make sure that before you start programming or try to look at the IDE, you would look at this number, or look at the problem, and try to solve it by hand. And as you're solving it on a piece of paper, you're going to see a pattern emerge. And when the pattern emerges, then you're ready to take to the next step, which is either writing the pseudocode based on that pattern, or write the flowchart. And then you're ready to actually program. Okay? So this is kind of like a pseudocode, right? Input first Fibonacci number and the desired Fibonacci number, output the end Fibonacci number. Right? So that would be the basic understanding. What do I need for my program? Okay? So then how do I come up with an arithmetic, an algorithm? Well, the algorithm would be to get the first two Fibonacci numbers and then get the desired Fibonacci number, which is the end position, and then calculate the next Fibonacci number. How do we do that? Add the previous two elements, and then repeat until the end Fibonacci number is found, and then output the end Fibonacci number. Right, so that's going to be kind of like a pseudocode. And then make sure that you go through this example in the book step by step. And all of these gray areas in the chapters explaining how to design properly a program, how to name your variables, how to comment your variables, and how to go about designing a program from scratch. It's a very good those are all very good examples. Okay. So in order to figure out the current value, you need to have the previous two values stored. You need to have a counter, and then the counter that we're going to be comparing to the end Fibonacci number. So counter going to be our loop control variable. And at that point you start converting your pseudocode into actual C++ code. So now you have variables, properly named variables. So how do we read in? How do we prompt the user? How do we read? How do we calculate the values? So we have the first two if statements. So if Fibonacci number is 1 or 2, then we basically just return either the previous one or the previous 2. Okay. And then, if the end Fibonacci number, what you read, is 3 or larger than 3, then you're going to have to start going into loop statements. And how do we figure out the current? Current is the previous 2 plus the previous 1. And at that point, we need to set the previous 2, the previous 1, and the current to previous 2. And that's going to give us the updated, the new previous 1 and previous 2 for the next iteration of the loop. And when you're done, you output the Fibonacci number. And so it's very important that you go through and load the code into the compiler and run it, and make sure that you put in the breakpoints in each iteration. Okay, so let's see if we still have the LF1 digits, so we're going to remove that, excludes from project. Save it. Okay, so add existing item. Okay. So we have the Fibonacci numbers. We add that in, and you can see how we have the initial values, the variables that we're going to hold, values in. Okay. And then we're going to read the first 2 Fibonacci numbers, and then which Fibonacci number that we need. Okay, so the best thing to do is put in the breakpoint. Okay, and what you can do is you can also put in breakpoints in the while loop to make sure that you can follow through with this code. Okay. Okay. So what is the end Fibonacci number? So let's say there is 1. So I want to see if we are going to get inside that if statement or that else statement. Okay. And then maybe then we are going into a new structure. Okay. And then you run it. Okay. Enter the first 2 Fibonacci numbers. Okay. 1 and 1. And then I want to see the first one. Okay. Now you can see that because I typed in 1, we actually caught that position right here. Fibonacci is equal to 1. So if we continue on, now you can see that we are inside the if statement because we did say 1. So at that point, the current is equal to previous 1, and previous 1 was the first value that we read. And at that point, we exited out of the program. Okay, so if you don't want to exit out of that, you can also put a breakpoint right in front of the return statement. Okay. So so let's see if we run this. And we have, let's say, let's say 3 and 5. Okay. And then we want to find the 15th Fibonacci number. Okay. We're looking at the if statement. See how we skipped over the if statement? This was false. because the nth Fibonacci number is 15, not 1. And then this was false because the nth Fibonacci number is 15, not 2. So we are in the else statement, and within the else statement, the counter we initialize to 3. Okay, and then we are in the while loop, and the counter is compared to the nth Fibonacci number. Okay, you continue on. Okay, now you can see that the counter is 4, the previous is 5, and the previous 2 is 8. Okay, and so now the current is 8. And we keep continue on, and now you can see the current is 13. Okay, and you keep continue on with the Fibonacci numbers. So now you can kind of control and see how the code is working. So don't just run the code, but make sure that you use the breakpoints and debug your code, monitor all your variables. Okay? So practice that. That's going to be very important for you to see how the code works with a code that's given to you. Okay, so keep practicing the sample code and read this chapter. Okay, do the review questions and bring questions next time if something doesn't make sense. Okay, so I'll see you guys next time.